Sanbonani Abafundi, welcome back to term 3, and we are carrying on with our study of algebra, and we are continuing to look at algebraic expressions. Let's dive straight in, and just a few reminders to get started with. Okay, the first thing is that in maths, whenever we learn a rule, that rule always applies. So the order of operations, BODMAS, EBODMAS, actually exponents first, still applies, right? We never, ever add unlike terms. So for example, x plus y just stays as x plus y. Remember that xy without a sign in between them means x times y. 2a means 2 times a. Right, we generally put factors in alphabetical order with the coefficient at the front. So in other words, we'd rather write 2ab rather than 2ba or ab2. Okay, 2ab is the best version. We put an equal sign on every line and we work downwards because we're not altering the value, we're just writing it in a different form. Okay, and then just a quick reminder of our exponent laws. We learned that when you multiply numbers with the same base, you add the exponents. So for example, if you've got a cubed times a to the 4, that will be a to the power of 7. Okay, and that makes perfect sense. It always makes sense. Because a cubed means a times a times a, 3 of them. A to the 4 means a times a times a times a, 4 of them. Altogether, we've got 7 a's multiplying together, and the shorthand for 7 a's multiplying together is to have a with a little power of 7. When we divide numbers with the same base, we subtract the exponents. So for example, if we had x cubed over x, remember that x is just like an x to the 1, that answer would be x squared. Right, 3 minus 1, okay? All right, another way of thinking about that, we've got 3 x's on the top, and we've got 1 x on the bottom. And if we divide both the top and the bottom by x, we'll be left with 2 x's on the top and just a 1 on the bottom. All right, no x. Okay, when we've got a product raised to a power, both the factors get the power. So for example, if we got something like 2x and we cube that, then both the 2 must be cubed and the x must be cubed. All right, so yeah, that's what it'll be, because 2x cubed, when you cube something, it means multiplied by itself and multiplied by itself again, right? So 2x times 2x times 2x. If we rearrange those things, there's 3 2's and 3 x's. Okay, same with what we call a quotient, a fraction. If we've got a fraction raised to a power, both the numerator and the denominator get that power. So for example, we had x over y to the power of 4, the x would be raised to the power of 4, so would the y be raised to the power of 4. If we've got a number with a power on it, and we raise that to a power, then we multiply the powers. So for example, if you've got something like x squared, and you choose to raise that to the power of 4, the answer is going to be x to the 8. Once again, this makes perfect sense. If we think about what does it mean to raise something to the power of 4, it means to multiply it by itself 4 times. So x squared times x squared times x squared times x squared. How many x's are there altogether multiplying there? Absolutely, there are 8. There are 2 here, 2 more here, 2 more here, and 2 more here. There it is, x to the 8. And finally, we know that a to the power of 0 is 1. Anything to the power of 0 is 1. Okay, right, let's dive in. And we're going to just also remember just 2 last things as we learned 2 rules called the distributive laws. Right, and these apply when we multiply a sum. Okay, so some things inside here by a number outside, or when we divide a sum and difference by a number outside. Okay, so in both cases, here we're dividing everything by d, here we're multiplying everything by a. Right, and what basically the distributive law says is that this a needs to multiply with each term inside the brackets. All right, and with the division, each term must divide by the d. All right. Okay, this one is, we should be fairly comfortable with this idea, because when we add fractions, for example, if we had 3/7 plus 2/7. I think you would agree that that would be just the same as 3 plus 2 all over 7. Right? They've got the same denominator. Now all we're doing is we're going the other way around here. Okay? We're saying that if we've got 3 plus 2 divided by 7, both the 3 must be divided by 7 and the 2 must be divided by 7. Okay, it makes sense. It always makes sense. Right, we're going to ask you to pause the video. We're going to ask you to try just the first 4 questions, just up to here, and then we'll go over them together. Okay, so the first one, we're just going to look for like terms. Right, these terms, 3x and negative 2x are like. Notice that I'm highlighting the sign in front of those numbers because that sign is really, really important. These terms over here, 4y and positive 7y, positive 4y and positive 7y are like. When we add them, we're going to get 3x and minus 2x. That's just 1x. Do we need to write the 1? No, we don't need to write the 1. Is it wrong to write the 1? No, it's not wrong to write the 1. But we generally want to save ink and save trouble, so we don't write the 1. 4y, positive 4y, add 7y, plus 11y. Okay. If you wrote 11y plus x, absolutely fine. Okay. You could write 11y plus x. That's just as good. What you cannot do is add those two terms because 11y and x are unlike terms. Okay, this one over here, 3x squared y plus 5xy squared. It's just going to stay exactly as it is. Don't leave it out, because if you leave it out, your teacher might think you don't know what the answer is. Just write it down again. We cannot add those two things. They are unlike terms. You might say, Paul, they look very similar. They do look similar, but I want you to look carefully. Here the x is being squared, and here the y is being squared. Right, they're different things. Okay, the next one involves BODMAS, the order of operations. The first thing we got to do is this multiplication. So we got 4ab, and then we're going to add, now we've got 2a times 6b. That's 12ab. Are these terms like? Yes, impela. So we can add them, and we get 16ab. Okay. Right, let's have a look at this. There are 1, 2, 3, 4 terms here. The only terms that are like are these two over here. 2y and negative 7y. The rest have to stay as they are. So this, notice we're drawing an equal sign. We're writing an equal sign, and then we're working downwards. So 5x. Then we've got 2y and negative 7y. That's negative 5y. Do you see how we're using integers? All right. And then negative 3xy. Negative 3xy, different type of term. Okay. All right. So we can't, that's where that stays. Okay. We're going to ask you to try the next 4. Pause the video, try them, and then let it play and see how you went. Okay, so let's have a look at this one. We've got our distributive law. This 4 needs to multiply by the x, which is 4 times x, 4x. But it also needs to multiply by the 2, which is 8. And then we've still got 3x. Is that correct? Yes, that's correct. Is it finished? We're not finished. No, because we've still got some like terms. This term over here and this term over here are like. We can add those. Right, and remember when we add them, the exponents don't change. We're not going to get x squareds. That's often a common error. People think when you go x plus x, you get x squareds. Okay, when you multiply x by x, you get x squareds. All right, our final answer here, notice we underline our answer to help the teacher find it and know that we've got it right. 7x, 4x plus 3x, 7x plus 8. We cannot add those two things. They're different things. They're unlike terms. Okay, number 6. We're going to multiply the 3 by the a and by the 2b. Then we are going to multiply the negative 2 by the a and the negative 2 by the negative b. So let's just have a look at what's going to happen here. 3 times a, 3a. 3 times 2b, 6b. negative 2 times a, negative 2a. And negative 2 times negative b. Careful, negative times a negative is? Negative times a negative is positive. Positive 2b squared. Sorry, negative 2 times negative b. Positive 2b. Okay. That line is exactly the same value as the line above it, right? Same value. That's why we're writing an equal sign. It's just in a different form. Now, we're not finished. And the reason we're not finished is there are some like terms. This term over here is like with this term over here. So 3a and minus 2a, what does that become? That's right, just 1a. Do we need to write the 1? No, we don't need to write the 1. Okay, we can just write a. All right, and then how many b's? Yeah, that's right. We've got 6 b's over here and 2 b's over here. 6 plus 2, last time I checked, 6 plus 2 was 8. 8b. 6 plus 2 is always going to be 8. That's the nice thing about maths. These things don't change. Right, now, the next two examples I'm going to do with you, okay, and then we're going to ask you to try some on the next page. So here we are just multiplying. Now, this is a normal 4 times a normal 3. Last time I checked, that was 12. Now, x squared times x squared. Okay, remember the rule that when our bases are the same, all right, these are both x's. When our bases are the same, we're going to add the exponents. So altogether, we've got 4 x's multiplying. When you multiply 4 x's, the answer is x to the 4. Here, we've got the same base. We've got a y, 5 y's multiplying together, and another 3 y's multiplying together. How many y's are there altogether multiplying together? There are 8. 5 plus 3. And that's how we write that. Okay. Now, let's have a look at this one. The square root of x to the 16. Okay, now, many of you, I know, many of you are going to say, let's square root 16 and get x to the 4. It's not right, okay? That's not right because, remember, when we square root, if we square our answer, then we should get back to x to the 16. And this is not correct. Okay. What number of x's must I put here? All right. If I was to square it, in other words, what number of x's squares to give me x to the 16? Okay, and remember when I've got a power and I raise to a power, I'm going to multiply. So what must this question mark be? Yeah, it almost looks a little bit like a question mark. It must actually be 8. Okay, so when we've got the square root of something to a power, we actually halve the power. We halve that power. All right, now this is now saying times x to the 4. Can we simplify this? And you might say, Paul, they're not like terms. Okay, but we're not adding. We are not adding, we are multiplying. We can always multiply things together. What's the shorthand for 8 x's multiplying with another 4 x's all multiplying? How many x's have we got all together? That's right, we've got 12. Our final answer, x to the 12. Okay, right, now we're going to stop there. We're going to end today's lesson there. We want you, before the next lesson, to try all the questions on page 4, and we'll go over them next time. We look forward to seeing you then. Have a great day, everyone.